So Milrain just asked an interesting question about USB 3.0. And the USB 3.0 standard or USB 3.1 Gen 1 standard, that's a USB-C interface. So it's an oval instead of a squarish looking interface, but it's still 5 gigs, it's 5 gigabits per second, right? And so if you wanted to see whether or not your thumb drive was 3.0 capable instead of being 3.0 compatible, you could simply take a 100 megabyte file, thereabouts, and what you end up with is 800 megabits, 800 million bits, okay? So a 100 megabyte file is 100 million bytes. Everybody with me?
Yes.
And if it's 100 megabytes, that means it's 800 million bits because there's 8 bits in a byte. And if it's 3.0 or higher on the port and the drive, if you divide by 5 billion, whoops, that's 5 billion. A 100 megabyte file should be finished transferring in, well, very quickly. I think that's supposed to be 16 seconds. I may have had 1 0 too many there. Let's try that again. 800,000,000,000. That's 800 million divided by, oh, no. Wait a minute. 8, yeah, 800 million bits. Oh, that's right. That's right. How large is your USB?
Oh, yeah. 32 gigabytes.
32 gigabytes. Okay. Do you have a 1 gig file? That might be a better test. So 1 gigabit is actually, 1 gigabyte is actually 8 gigabits. And if I divide it by essentially, it's going to happen very fast. But if you take a 1 gig file and you drag it onto your USB and it takes, close to a minute, that's an older style USB drive. Okay?
Okay.
Yeah. Sorry for the math part. I'll work up some quick tests and then record a short video to do that. Do we have everybody? Nope, we don't. We have Akeem with us now. Good afternoon,
Yes.
Akeem.
Good afternoon.
Yes. So does everybody see my screen?
Yes.
All right. Welcome back. It's Friday, 10 February. This is Operating Systems Deployment Best Practices. We touched on a concept on Wednesday where we wanted to define the difference between straight install media for an operating system distribution or distros, and whole system images. And essentially, if you create an entire system, you can engage, if you create an entire system with all of the software configured for the local environment, the difference between a distro is that it's a general configuration. But you can take an OS, install all the software, and then configure it for a local system so that it uses the same DNS server, so that it's pre-configured to use certain shared network resources, so that it's pre-configured to have the latest video drivers, the latest touchpad drivers, the latest fingerprint reader drivers, stuff that's specific to the local environment, which isn't generally included in a distribution. A great example of this would be a computer lab system. So at the UVI campus, there are computer labs. There's an entire suite of software, but basically each of those machines need to be a part of the local environment. So there are additional customized settings that have a lot to do with the specific needs and interests locally that you won't find in a distribution. And if you create and get the system ready from scratch, and by scratch I mean bare metal install, for a given brand and model of hardware, basically for a given CPU and motherboard chipset family, you can generalize up to a point, right? So if you have like 9th generation i7 Intel processors, and you have the same chipset in a variety of Dell computers, you can generalize to a point. Then you make a clone of the system by running a tool called sysprep. Okay, sysprep.exe. And that allows you to make an image so long as you have the space to capture it, right? Once you have the image, you can use it with a distribution server, a special server, and basically photocopy that machine out to hundreds of screens simultaneously. It's just a thing of beauty. Now, we are going to talk about essential considerations for the prep of install media and system images. There are some special considerations that we want to point out before we do this, but I also thought it would be a good idea to show you the option. So I went onto my own system, and you'll notice that there is a folder inside the operating system volume, or sys volume. The operating system volume is often referred to as the directory or path where your operating system itself is installed. And in Windows, that's Windows, the Windows directory, and then System 32 is where many of the OS internals are located. There's a separate subdirectory called sysprep, and then sysprep.exe is in there. I'm going to open the file location with a right mouse click. And here I have the sysprep application. Now, before I kick this off and show you what it does, and I won't be able to complete the process, because when I do that, it's gonna disconnect the network, and then it's gonna put my laptop in a different mode. What I'd like to do is go ahead and cover this objective, right? Provide essential considerations for the prep of install media and system images. I'm going to type a statement here. Have you ever heard to err is human, but if you really want to screw things up, use a computer? Actually, this is the start of the quote. Has anyone ever heard this quote?
I've heard the first part, not the last part.
To err is human, but if you really want to screw things up, use a computer. Now, I want to, this is something that I think we brought up in our virtual machines class. I have a distribution that I can use to set up machines. And I have a variety of distributions. This is a Raspberry Pi ISO I can use to set up the Raspbian. I don't know if you're familiar with a Raspberry Pi, but I can set up a machine and a virtual machine that acts just like a Raspberry Pi. But let's pretend that I want to do something a little more than that. So I'm going to go to a demonstration machine, right? Can everybody still see my screen?
Yep.
Yeah.
Great. And let's pretend I want to use Orion for a demonstration machine. I'm gonna see if I can adjust this a tad just to make it a little bigger. All right. Can everyone still see the screen?
Yep.
Yeah.
Okay. So let's pretend that I have a server and I'm setting it up for student use, and I want to install all sorts of things. And when I look at it, I find out oh, it's not up to date. Okay. And let's pretend I want to check to see what exactly the version is, right? So I'm going to go to the systems option and I'll go to about. And let's pretend that I'm on version 1809, right, of server 2019. And the latest version of 2019 is 22H2. The first two numbers generally represent the year it came out. Although it was later in 2018, so technically I guess you could say 2019. How much time has passed between 2019, 2020, 21, 22, and now we're in what year?
2023.
2023. There have been several new feature releases, each requiring gigabytes, like 3 or 4 gigabytes, conservatively 4 gigabytes each. Gigabytes multiplied by 8, 32 gigabits. 32 gigabits, and there's 3 of them, right? So if we do the math, 32 times gigabits times 3, that's 96 gigabits. All right, let's round it up, 100 gigabits. So if I had a 1 gig connection to the internet, it would take a while to download each of those. Then it would take a while to install them. And then perhaps I also have new drivers, right? The point I'm trying to make is if you're working with a system that you want to be an image, we did say that it needed to be a bare metal installation, correct? A clean installation. But it also needs to be an updated installation. It needs to be a current installation. And ideally, what you want to do is install these things without connecting it on the internet. And you might say, well, how the heck do I do that? There's a site called the Microsoft Update Catalog, right? I'm pretty sure we've covered this. And you can search for a specific update to include a feature release, that 4 GB thing, right? And if you're going to do this for 100 machines, wouldn't it make sense to like build out the 3 rounds of 32 gigabit updates, you know, the new versions first, right? Because if you roll out to 100 machines and then surprise, they're all out of date, what's the first thing they're going to do when they connect to the internet? What did this machine start to do as soon as it got on the internet? I mean, it started saying, hey, you don't have the latest, didn't it? Didn't I see that almost immediately?
Yeah.
It popped up and said, hey, you don't have the latest, right? So what do you think happens when 100 of those bad boys connect to the network and they're all saying, hey, you have some updates, right? Oh, look, cumulative updates. Those are monthly ones, but then there are feature releases. Those are the major updates that move you from one whole version of the operating system from 1809 to 21H2 or 20H2 to 21H2 to 22H2. So those are whole kernel updates. And then there's all these cumulative updates. Now this is just a monthly cumulative update for the month of December. And I may have demonstrated this in some other classes we've had. But let's just take the cumulative update for Windows Server, not the cumulative update for the .NET programming framework. Let's just take the operating system itself. Okay? 502.2286. 502.2286. 502.2286. Everybody with me? You see what I'm doing here?
Yeah.
Right. Now for Server 2019, we have a version for Windows 10, but we also have a version for Windows 2019. How much is that? That's just the January 2023. That's the monthly update. That's 600 megabytes. Everybody see that?
Yep.
Okay, that's not a feature release that's 3 gigabytes large. This is 600 megabytes. So each month there's between 300 and 600 megabytes that update to fix critical security problems. And why are we doing that? Well, I don't know if you know this, but we're in a state of war. I'm going to download this, by the way, just for giggles, because I want you to see what happens here. We're going to close this. I'm going to see if I can find the latest Windows 11 update. So I'm going to go into here and go into System, and then About. Well, no, I'll go to Windows Update. Ah, there's a cumulative update for Windows 11, and there was a previous Windows cumulative update for the .NET framework that failed. Does everybody see this?
Yeah.
You can click download and install on the machine you're prepping for an image. But the problem is you're connected to the internet. That's the problem. What you should do instead is take 502.2360, 502.2360, and here it is. I'm using the x86. Now, ARM means that's a RISC processor. So you would use that for perhaps the M1 chipset if you're running boot camp on a MacBook Pro or on a tablet that has a RISC processor and you're running Windows on the tablet. I'm going to download this, and essentially, why should you care, right? So I'm gonna click download, and that's going to download this update. When you have these on a separate thumb drive, all you have to do, and I'm going to demonstrate this in class because this is actually a good way to go. I'm going to download this separately, and instead of, I can disconnect from the internet. And if I'm creating a bare metal installation with a sterile installation media, right? And I have the known updates that I need. I have a collection of those for each month and for each whole year version, upgrade. Then I don't even have to connect to the internet. So I stand a much greater chance of building the system where it's bare metal, it's clean, and no uninvited guests hitched along. And why do you care about uninvited guests? All it takes is one whole system image with an uninvited guest, and when you use that to roll out the photocopy machine on steroids to 100 different screens, guess what you've just created? 100 different instances of the uninvited guest. Okay? So if you'd like to understand an essential consideration for the preparation of install media or system images, if you're using these in any numbers, you want to make sure that what you're building is completely sterile. And there's a very good way to do that. You go to the Microsoft Update catalog and you look up each of the knowledge base articles for each of the updates that have occurred since the last update. Now, this may seem like a very daunting task. It may seem like a very daunting task, but the truth is, when I connect to, let me do this here and I'll show you. Everybody with me so far? So if I look at my media and I want to see, well, where was I? I was just there. Can everybody see this?
Yes.
That specific code tells me exactly which version of Server 2022 was used to create this ISO. And I could actually open this up and I could include the MSU downloads, the Microsoft Update downloads in a folder inside this disk. Now, why would I want to do that? Because if I download it once and then I use this disk, when I'm finished installing the OS, I can leave it in the disk tray, open up the directory, and double click, double click, double click, double click, and I'm loading, 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 loading. That's one shortcut. But it's even better if I go ahead and install all of those Microsoft Update downloads on an air-gapped machine that isn't connected to the internet, and then I run sysprep. Because what I'm doing is taking clean media the entire way, and I'm building out the rest of the system, and I'm updating without having to be on the internet. And that's just one thing that I'm, plus if you have a copy of those on a thumb drive or you have a copy in a directory, you're not sucking up huge amounts of internet service. It's an amazing thing to see 100 machines. All right, let's give you a different analogy. It's amazing to see 100 machines kick off because the image that was captured with sysprep wasn't complete. And 100 machines simultaneously say, oh, I have to download a new version of Windows. And they all try to download a 4 gigabyte footprint, 100-fold, all at once. What do you think an entire organization's network does when that hits the internet? Would anyone care to guess what happens?
Probably slows it down a lot.
It slows it down so badly, the phone starts ringing off the hook. Hey, I can't read email. I can't pull up my files. What the heck is going on? It is so bad. But I don't have to convince you that 100 lab machines all downloading new feature updates or feature releases, right? New whole versions of the operating system. I can tell you from personal experience, in my former post, I was the lead technology person for the entire campus. And we had a series of dormitories, just like you do at St. Thomas. And so there were 4 dormitories, 4 primary dormitories. And the male dorm in particular, we had 2 co-eds, a female and a male dorm, all right? And in the male dorm, it was kind of like a frat house. And one day we got calls ringing off the hook, right? Everybody's saying, hey, nobody can do anything. Nobody can, never mind the Netflix or the Hulu. Nobody can do any work at all. And we basically traced things back to 3 gentlemen in the male dorm. And they were on like a searching party. They were on like they were basically having a contest to see who could download the most porn and who could watch the most. So they had started this crazy contest. It was like, okay, I can play 3 movies in 3 different windows. Now my system can play 4 different movies in 4 different windows. So we had 3 guys on 3 laptops, and they were running a variety of adult video clips simultaneously at the same time. And it was some kind of contest. And the entire that part of the campus slowed to a crawl. And we basically had to say, look, guys, if you're going to do this kind of thing, rent a hotel room and, and get a room, right? But be good citizens. Don't jam up the work. And they didn't realize they'd shut the whole place down. It was pretty bad when here's a knock on the door and they're like, yeah, you got to give me a minute. Like, we noticed that like a gigabit a second is coming through your port. He's like, yeah, I was doing some research. What about it? I'm like, yeah, well, you weren't the only one, but basically whatever you were looking at, you can't do this anymore. The entire campus is messed up. So just think, if 3 young men just simultaneously doing what 3 young men may do from time to time. And this was in the middle of a business day, in the middle of the class day, right? So classroom professors were calling, nobody could do anything. My point is that gigabit access to the internet is not a common thing. And it doesn't take much to end or to max out a gigabit. Doesn't take much. And so there's great power when you use sysprep, but the challenge is to understand there's a multiplier effect. So you absolutely want to prepare an entire system image with things either pre-bundled in the install media. Just create a separate directory and call it MSUs and put it in there. And then every system you set up with that, you have everything you need without connecting the internet. Or use those MSUs, which by the way should be finished now. There it is. There's my MSU. Can everybody see this? Hello?
Yeah.
So everybody can see this. Okay. So why would you care to download an MSU? And what's the advantage of keeping this on a thumb drive? Well, every time a Windows 11 machine has to load that thing, it's stuff, again, it's stuff you don't have to keep downloading and downloading, but how do you apply it? Well, that's the cool part. I'm here and I could click download and install. Right? And here I have a cumulative update for .NET Framework. I have to install, but it keeps failing. So how do I get that in the image? How do I get that in the image if I can't get it to load the natural way? 502.2404, right? What do I do? 502.24. Everybody sees what I'm doing, right? Search.
Yes.
Oh, here we go. Windows 11 22H2 cumulative update. Oh, and it's only 55 megabytes, but it keeps failing. Download, download, right? So does it fail because it can't install the rest of the way with a network load? Maybe. Maybe if I have a local copy and I can just load it, it'll finish, right? Maybe if some other services aren't running, like, I don't know, a Zoom session with upstream traffic where I'm sharing the video, a whole variety of things could be impacting how this works. The important thing to understand are the dependencies and how the multiplier effect, it's good, but it's also bad. Has anyone ever seen a Japanese steakhouse and a master at the hibachi? Has anyone ever seen that?
Yeah.
Okay, and you know what a Ginzu knife is, right?
I think so.
So it's what they use.
Like to cut up the salmon and the steak and stuff.
Oh, exactly, right? And all right, so here we could watch like a real quick demo of how these guys work. So I want you to cross a chainsaw with a Ginzu knife. That's the equivalent, that's the digital equivalent of what we're talking about when you work with images to multiply and duplicate massive. Now, this is also very powerful because if you have a runaway infection and half the machines on your campus are infected, oh my gosh, how do you get half the people in your organization back up and running quickly? Well, they go home Friday afternoon a little early and you run this thing because you have a new image and it's, what is it? It's sterile, it's locked down, it's hardened, and that infection isn't coming back. And then you, because you've configured their user files to store on a file server, you don't have to worry about saving work off of their machine. You just blow it up. Because their work is already stored not on the local user profile in here, in users, like here's my local user profile. In a domain environment, this user profile can be made a roaming profile. I can store it on a fast server, so no matter where I log in, it doesn't matter where I log in. I can be anywhere on campus, log in, and all my documents, all my shortcuts, all my media, my videos, everything, my pictures, All of it is all right there. And when I open up my machine, I see there are network drives that are connected. And we're gonna explore how to set those up and use those. That's another part of the power. So what am I saying? You can wipe half of the machines on campus and load them from scratch, and you know it's sterile. And then when people log in, they get all of their stuff because it was never in the C drive. It was never in the user's folder. It was already stored on a server somewhere else. And that's how it's set up. Now, what we're referring to here is a domain environment as opposed to a standalone environment. Have we talked about this yet?
I don't think so.
Okay, well, we're going to do that. I'm going to borrow a quick screen from another course, but it's going to be incorporated into the draft of our study guide. Okay. Oh, wait a minute. Hold on. I think it was the addendum. Hang on a sec. Let's look at this. Oh, nuts. I just had this. Hold on. Oh, all right. My apologies. Stand by. Oh, this is kind of embarrassing. Thought I had this in here. I was showing another class this just a little while ago. Let's go back one more time. There it is. Okay, my apology. So that gap where I was trying to find this and I couldn't find it. Can everybody see the screen?
Yeah.
Okay. So we were just talking about a case where essentially in a domain environment or a centralized enterprise security account management context, in mid-size and larger corporations, organizations, government agencies, and so on, they organize their infrastructure differently so that there's centralized management. Instead of having user profiles in the local hard drive, you can configure servers to store those so that users can log in on any machine and their documents, their videos, their pictures, everything follows them. The trick to this is understanding the difference between the two models that are used to manage security accounts. And when you're working operating system deployments, if you're working the standard security model or standalone security model, this is often called a work group. The work group model. And if I look at my machine and I look at my system and then look at the advanced parts about this, I can go to the advanced system settings and I have a computer name. And normally the default name for a work group configuration so that computers and tablets and laptops can see each other on a network, it's called work group. Kind of like the default password for a Wi-Fi router is password. Okay, is everybody with me so far?
Yeah.
So if you're in a work group mode, your security accounts are all managed standalone on each system. Put another way, the security accounts exist only on each separate system. And so what am I saying? If you're working operating system deployment in an environment where there's more than 4 people, you should be operating in a domain environment with a special server called a domain controller, where all of the user accounts, computer accounts, system accounts, service accounts, everything is centrally stored on one server. Here's why. Let's say we're all in the same classroom and you want to share files with 4 of your peers. And you each have your own machine out of the box and every one of them is configured to the work group, okay? Everybody with me? And here I have 4 PCs, one for Rhonda, one for Ranel, one for Jesus, and one for Kana. Now let's say that Rhonda wants to share her work and do her stuff. Not only is her user profile stored on the local machine, but she would have to set up a login account for Ranel, a login account for Jesus, a login account for Kana on her own machine. And she'd have to maintain those. Now, if Ranel, Jesus, and Kana wanted to seamlessly connect to her system to share stuff, they would want to get on her screen and put in the same password they use to log in on their machines. Does everybody follow what I'm telling you? Everybody with me?
Yeah.
Yeah.
Now let's say that Ranel wants to do the same thing. Ranel has to set up a separate login account for Rhonda, a separate one for Kana, a separate one for Jesus. And Ranel has to say, hey, Jesus, come over here. Rhonda, come over here. Kana, come over here. I want you to log in and set up your password, right? Same thing with the Jesus. That's standalone security account management. And that's the default. Unless you form an enterprise or unless you create the infrastructure for a larger environment, this is the world you live in. And the user profiles are stored here on each of the separate machines. And each of those user profiles are not the same as the user profiles. So when Ranel logs in on Rhonda's, when he looks in his directory, in his documents, in his video, he's going to find out, well, they're not there. They're actually over here, right? So he can log in and share resources that Rhonda wants to share with him, but it's complicated. The point is that so is automated operating system install. If you have a domain, what happens is that Ranel, Kana, Rhonda, and Jesus have their user accounts stored on the server. And if Ranel changes his password, he doesn't have to go to 3 other machines to change his password. And Ranel's user profile is stored on a central server, not on the local PC. The same thing is true for Rhonda. She doesn't have to go to 3 other machines to change her password, including the change of password on her own machine, in order for everything to continue to work. And if she signs on here, there, and the other place, her user profile is right where she's logged into because of this arrangement. This is called enterprise security account management, or Active Directory. The Microsoft version of this is called Active Directory. So this is one of those things that you want to encourage if you're doing automated setups for a company or an organization, and you want to start making your life easy. One of the conversations you want to have with them about deploying, maintaining, supporting, troubleshooting, configuring operating systems so that everybody can get to their stuff where they want, how they want, when they want. You want a domain, an Active Directory domain. And if you have just 4 machines or more, it's worth its weight in gold. It saves all kinds of trouble. It makes deployment, it makes every aspect of operating system support and installation and reconfiguration. If something goes up, it goes boom, it blows up, it goes boom. Your ability to recover very quickly with automated processes is increased 1,000-fold, and the cost of the server is conservatively $500-600. It's not a lot of money. And small business environments are always trying to save a little money, but that's one place they don't want to save money. Now, that's the last I'd care to share with you today about automated methods and the considerations you want to take. Remember that it's a multiplier effect. Remember that an enterprise environment is where it works best. And remember that if you can set up an image and capture it, when you run sysprep, there's an option called UBI. And I'm seriously thinking about setting up a lab where you remote into systems and you run UBI so you can experience what it's like. What do you say the solution for this module involves running sysprep on your own server, not your laptop? We don't want you to blow up your own stuff. Would any of you agree that doing this on a remote system so you could experience how that works would be a good idea?
Yeah, definitely.
Okay. I can set this up over the weekend and I'll set up logins for you. And we'll take up a review of how to connect and what to do with your own server. But what I'd like you to do is to, after your login, put something on the desktop, put a quick text file in documents, kind of make it your own. And then when you run sysprep, you'll see what happens when those changes are replicated, right? Any questions about what we've covered today before we clear for the weekend?
Done for me.
Okay, once again, sorry for the fumbles early in the class. And when we got to that point about enterprise security account management, and I'll edit those out of the video before I post it so that if you want to review this material again, you won't have to wait for all that.